Welcome to our comprehensive guide on secure Android app development, specifically tailored for Kotlin developers. In the fast-evolving world of mobile technology, security is no longer optional, it's a necessity. Many developers treat security like an afterthought, only addressing it after a major issue arises. However, with the increasing sophistication of threats, a proactive approach is essential. In this video, we'll explore the modern Android security architecture, breaking down the latest pattern. Security in mobile development is often compared to insurance, something many skip until disaster strikes. But for Android engineers, the stakes are high. User data is sensitive, and breaches can have severe consequences, both for users and for your app reputation. By integrating security from the very beginning of your project, you can avoid costly fixes and ensure a safer experience for everyone. In this scene, we'll discuss why security should be a foundational part of your defense-in-depth approach means layering your security measures so that if one fails, others are in place to protect your app and its data. This proactive strategy involves considering security at every stage, from high-level design to the smallest details of your Kotlin code. By thinking ahead and anticipating potential threats, you can build robust defenses that adapt as the Android platform evolves. Let's explore how to implement this mindset in your development workflow. Android security standards are constantly changing. What was considered best practice just a few years ago may now be outdated or even insecure. Staying up to date with the latest security paradigm is crucial for developers. This means regularly reviewing your code, updating dependencies, and following the latest guidelines from trusted sources. In this scene, we'll highlight the importance of continuous learning and adaptation in secure app development. Security should be integrated into your app's high-level design from the very start. This means considering how data flows through your application, identifying potential vulnerabilities, and planning for secure interactions between components. By addressing security at the architectural level, you lay a strong foundation that makes it easier to implement effective protections later on. Let's look at how to incorporate security into your HLD process. Once your high-level design is secure, it's time to focus on the details. Writing secure Kotlin code means being aware of common pitfalls, such as improper data handling or insecure API usage. By following best practices and regularly reviewing your code, you can catch issues early and prevent vulnerabilities from slipping through. In this scene, we'll discuss key considerations for secure Kotlin development. Modern data security stack is essential for protecting information as it moves through your app. Each layer acts as a gatekeeper, ensuring that only authorized data reaches physical storage or external API. By structuring your data pipeline with security in mind, you can prevent unauthorized access and reduce the risk of breaches. Let's break down the components of a secure data stack and how they work together. Each layer in your data stack serves a unique purpose, from input validation to encryption and access control. By layering these protections, you create multiple barriers that attackers must overcome to access sensitive information. This approach not only strengthens your defenses, but also makes it easier to identify and address vulnerabilities. In this scene, we'll explore how to implement layered data protection effectively. Validating user input is one of the first lines of defense against security threats. By ensuring that all data entering your app meets expected formats and constraints, you can prevent common attacks like SQL injection and buffer overflows. Input validation should be performed at every entry point, including forms, API, and external data sources. Let's discuss best practices for robust input validation. Encrypting sensitive data is crucial for protecting user privacy and preventing unauthorized access. Whether data is at rest or in transit, strong encryption algorithms should be used to safeguard information. In Android development, you can leverage built-in libraries and API to implement encryption without reinventing the wheel. Let's look at how to apply encryption effectively in your app. Access control mechanisms ensure that only authorized users and components can interact with sensitive data. By defining clear permissions and roles, you can limit the potential damage caused by compromised accounts or components. Implementing access control at multiple levels, such as user authentication, API keys, and internal checks, adds depth to your security strategy. Let's explore how to set up effective access control. Storing sensitive data securely is a critical aspect of Android app security. Use encrypted storage solutions and avoid saving confidential information in plain text or easily accessible locations. Android provides several secure storage options, such as the key store system and encrypted shared preferences. By choosing the right storage method, you can protect user data even if a device is compromised. API are a common target for attackers, making API security a top priority. Always authenticate and authorize API requests, validate input, and use secure communication channels like HTTPS. Regularly review your API endpoints for vulnerabilities and follow the principle of least privilege when granting access. In this scene, we'll cover essential practices for securing your app's API. Understanding the threats your app faces is the first step in building effective defenses. Android apps are vulnerable to a range of attacks, including malware, data leakage, and unauthorized access. By staying informed about the latest threats and attack vectors, you can design your app to resist them. Let's examine some of the most common threats in the Android ecosystem. Malware is a persistent threat in the Android ecosystem. Attackers use malicious apps and code to steal data, compromise devices, and spread further infection. By following secure coding practices, using trusted libraries, and regularly scanning your app for vulnerabilities, you can reduce the risk of malware affecting your users. Let's discuss how to defend against malware. Data leakage occurs when sensitive information is unintentionally exposed, often due to insecure storage or transmission. Preventing data leakage requires careful handling of user data, strong encryption, and secure communication channels. Regular audits and monitoring can help you detect and address leaks before they become serious problems. Let's explore strategies for preventing data leakage. Unauthorized access can occur when attackers bypass authentication or exploit weak permission. Implementing strong authentication methods, such as multi-factor authentication and regularly reviewing permissions, can help prevent unauthorized access. In this scene, we'll discuss how to secure your app against unauthorized users. Writing secure code is the foundation of a safe Android app. This includes avoiding hard-coded secrets, validating all inputs, and handling errors gracefully. By following established secure coding guidelines, you can minimize vulnerabilities and build more resilient applications. Let's look at some key secure coding practices every developer should follow. Third-party libraries and dependencies can introduce vulnerabilities if not managed carefully. Always use trusted sources, keep dependencies up to date, and monitor for security advisories. By regularly auditing your dependencies, you can reduce the risk of introducing insecure code into your app. Let's discuss best practices for managing dependencies securely. Authentication is a critical component of app security. Implementing strong authentication methods, such as biometrics or multi-factor authentication, can significantly enhance your app's defenses. Always store authentication credentials securely and avoid exposing sensitive information. Let's explore the latest authentication techniques for Android apps. Authorization determines what users and components are allowed to do within your app. By defining clear roles and permissions, you can prevent unauthorized action and limit the impact of compromised accounts. Regularly review and update your authorization control to adapt to changing requirements. Let's discuss how to implement effective authorization. All communication between your app and external services should be encrypted to prevent eavesdropping and tampering. Use protocols like HTTPS and TLS to secure data in transit. Regularly test your communication channels for vulnerabilities and ensure certificates are valid. Let's explore best practices for secure communication. Proper error handling can prevent attackers from gaining insights into your app's inner workings. Avoid exposing sensitive information in error messages and logs. Handle exceptions gracefully and log only what is necessary for debugging. In this scene, we'll discuss secure error handling techniques. Managing user sessions securely is vital for preventing hijacking and unauthorized access. Use secure tokens, set appropriate timeouts, and invalidate sessions after logout or inactivity. Regularly review your session management logic to ensure it meets current security standards. Let's look at how to manage sessions securely. Effective logging and monitoring help you detect and respond to security incidents quickly. Log important events, monitor for suspicious activity, and set up alerts for potential breaches. Ensure that logs do not contain sensitive information and are stored securely. Let's discuss how to implement robust logging and monitoring. Regular security testing is essential for identifying and fixing vulnerabilities before they can be exploited. Use automated tools, conduct code reviews, and perform penetration testing to assess your app's defenses. By making security testing a routine part of your development process, you can catch issues early and maintain a strong security posture. Keeping your app and its dependencies up to date is crucial for security. Regularly release updates to patch vulnerabilities and improve defenses. Notify users about important security updates and encourage them to install the latest version. Let's explore how to manage secure updates effectively. Educating your users about security best practices can help prevent common attacks like phishing and social engineering. Provide clear guidance on creating strong passwords, recognizing suspicious activity, and reporting issues. Empowering users to take an active role in their own security strengthens your app's overall defenses. Having a plan for responding to security incidents is essential. Define clear procedures for detecting, reporting, and mitigating breaches. Regularly review and update your incident response plan to ensure it remains effective. In this scene, we'll discuss how to prepare for and handle security incidents. Many apps must comply with legal and regulatory requirements, such as GDPR or HIPAA. Ensure your app meets all relevant standards for data protection and privacy. Regularly review compliance requirements and update your policies as needed. Let's discuss how to stay compliant with security regulation. Conducting regular security audits helps you identify weaknesses and ensure your app meets security standards. Use both internal and external auditors to review your code, architecture, and processes. Address any findings promptly to maintain a strong security posture. Let's look at how to conduct effective security audit. Security by design means integrating security considerations into every stage of your development process. From initial planning to deployment, always think about how to protect your app and its users. This proactive approach reduces the risk of vulnerabilities and builds trust with your audience. Let's explore how to apply security by design. Principle of least privilege means giving users and components only the access they need to perform their function, nothing more. This limits the potential damage from compromised accounts or components. Regularly review permissions and adjust them as necessary to maintain tight control. Let's discuss how to apply this principle in your app. Always configure your app and its components with secure defaults. This means disabling unnecessary features, enforcing strong security settings, and requiring explicit opt-in for risky action. Secure defaults help prevent accidental exposure and make it easier to maintain a strong security posture. Let's explore how to set secure default. Security is an ongoing process, not a one-time task. Continuously monitor your app, review your practices, and stay informed about new threats and defenses. By fostering a culture of continuous improvement, you can adapt to changing risks and maintain a secure app over time. Leverage community resources such as forums, open source tools, and industry guidelines to stay up to date with the latest security trends. Engaging with the developer community can help you learn from others' experiences and improve your own practices. Let's discuss how to make the most of community resources. Integrating third-party services can add value to your app, but also introduces new risks. Always vet third-party providers, review their security practices, and limit the permissions you grant them. Monitor integrations for suspicious activity and update them as needed to maintain security. Your app's security also depends on the security of the devices it runs on. Encourage users to keep their devices updated, use strong passwords, and enable device-level encryption. By promoting good device security practices, you can help protect your app and its data. Complying with App Store security guidelines is essential for getting your app published and maintaining user trust. Review the latest requirements for the Google Play Store and other platforms and ensure your app meets all security standards. Let's discuss how to navigate App Store guidelines. Securing your build and deployment pipeline is just as important as securing your code. Use secure build environments, sign your app with strong keys, and automate security checks as part of your CI/CD process. By securing your pipeline, you can prevent tampering and ensure only trusted code is released. Obfuscation makes it harder for attackers to reverse engineer your app and discover sensitive logic or data. Use tools like ProGuard or RR to obfuscate your code and resources. While not a substitute for other security measures, obfuscation adds an extra layer of protection. Defending against reverse engineering involves more than just obfuscation. Implement runtime checks, detect tampering, and use native code for sensitive operations when possible. By making it harder for attackers to analyze your app, you can protect your intellectual property and user data. Documenting your security policies and procedures helps ensure consistency and makes it easier to onboard new team members. Keep your documentation up to date and make it accessible to everyone involved in your project. Let's discuss the importance of thorough security documentation. We've covered a wide range of topics in secure Android app development, from high-level design to low-level coding and ongoing maintenance. By following these best practices and staying proactive, you can build apps that are resilient to modern threats and trusted by users. Let's recap the key takeaways and reinforce the importance of security in every stage of development. The Android platform continues to evolve, so do the threats and defenses. Stay curious, keep learning, and adapt your security practices to meet new challenges. By making security a continuous priority, you can ensure your apps remain safe and reliable for years to come. Thank you for joining us on this journey through modern Android security architecture.